Alright, let's take a look at the PowerPoints for Chapter 1, Section 1.1, What is Mathematics? What do you think? Respond to the prompt. Mathematics is... Describe a few of your experiences learning mathematics. What does it mean to learn mathematics? You are at the beginning of a course where you will re-examine elementary school mathematics to understand these concepts on a much deeper level and to learn why the mathematical procedures and formulas actually work. On this journey, you will learn several ways to see and think about concepts and procedures that you may have previously simply memorized. The deeper understanding will lead to increased confidence and comfort level with mathematics. Mathematics is both beauty and truth. 2 plus 2 always equals 4. The distance around a circle is always a little more than 3, actually pi, times the distance around the circle. Throughout this book, we hope you will appreciate more and more the beautiful truths of mathematics. Your approach to learning and teaching mathematics depends on the attitudes and beliefs you bring. In subtle and not so subtle ways, they may affect your learning of math, and you may pass these beliefs along when you enter the classroom as a teacher. Reflect on how you answered the questions above. Whatever your feelings about mathematics, consider where these feelings come from. Research suggests that people who have math anxiety can relate it back to a teacher and/or experience in their elementary or middle school years. Think about the best math teacher you have had as well as the worst math teacher you have had. Consider the skills and qualities that each of them had that led to your experience of them. What skills and qualities do you have and need to further develop to become an excellent math learner and teacher? Mathematical growth mindset. Do you have a fixed mindset or a growth mindset when it comes to learning math? Take this survey to find out. 7 pairs of statements are given in Table 1.1. Score your beliefs in the following manner. If you strongly agree with the statement in column A, record 1. If you agree with the statement in column A more than column B, record 2. If you agree with the statement in column B more than column A, record 3. If you strongly agree with the statement in column B, record a 4. In Table 1.1, the statements in column A indicate a fixed mindset, and the statements in column B indicate the corresponding growth mindset. If you take the arithmetic average or mean of your scores by adding up your scores and dividing by 7, you will get a number that we could call your belief index. If your belief index is low, you are currently in more of a fixed mindset. The main goal of this book is to help you understand math in a conceptual and flexible way to help you foster a growth mindset toward math and increase your self-confidence about math, which in turn you can pass on to your students. Many people see math as a set of rules and formulas to memorize instead of connected concepts that make sense. Deepening your understanding of mathematics through your studies will help you to have a positive attitude about math. The essence of a math growth mindset is to approach math conceptually, seek understanding, and believe that everyone can learn math. If you have been told that you do not have a math brain, or you learn to believe this, it is not true. Recent brain research shows us that with the right learning opportunities and beliefs, everyone can learn math and reach high levels of math. Henry Ford is quoted as saying, "Whether you believe you can do a thing or not, you are right." As you engage with this book, believe you can make sense of the math concepts. If you catch yourself saying anything like, "I'm not good at math," change that to, "I can learn math." By changing your words, you can change your mindset. That is the first step in learning and creating a growth mindset. Approach the concepts in this book with an open mind toward learning and a belief that you can learn the concepts. Your future students are depending on you to deepen your understanding of math and develop a growth mindset so that you can teach them. In our current performance model of schools, where getting the right answer is valued, mistakes are seen as bad. However, recent brain research provides evidence that mistakes actually help our brain grow. Our brains grow even more by making a mistake and learning from it. When you follow a path on a math problem that does not get you to the answer, go back, see where you went down a non-productive path, and correct the way you are thinking about it. Studies of successful people show that they make many more mistakes than unsuccessful people. Therefore, as you read through this book, be comfortable exploring ideas and making mistakes. Learn from your mistakes. Persevere through the solution, and success will be yours. Owning versus renting. You will notice that I often ask you to stop, think, and write some notes. I really mean it. Many students rent what they have learned just long enough to pass the test. However, within days or weeks of the final exam, it's gone. If you make sense of what you're learning and make connections, then you will remember the concepts. One of the important differences between students who own what they learn and those who simply rent is that those who own the knowledge tend to be active readers. Mathematical knowledge for teachers. Having a mathematical growth mindset is especially important for teachers, both in their own learning and their ability to help their students. In Investigation 1.1a, more than one way to multiply. First multiply 49 times 25 using any method you choose. Then consider how the following students solve them. What method do you think each student is using in each solution below? Do you think each method will work for any two whole numbers? We use this example to illustrate how part of the teacher's role is to first have a math mindset that there are different methods for solving problems, to be able to develop, understand, and communicate different strategies, and to see the connections between them. This book is not about methods of teaching. It is about developing a deep and flexible understanding of math and developing a mathematical growth mindset. Student A used the method of 5 times 49 and 20 times 49 that many of us learned in elementary school, especially if we went to school in the United States. Different and equally effective methods are taught in other countries, and we will look at some of these in this text to deepen our understanding. Some of us learned to write the second row in the multiplication as 980, and some were taught to move over a space as shown here. Why do we do this? Because we are multiplying 49 times 20, not 49 times 2. So we write it as either 980 or as 98 with the space in the ones place. Either way, 8 is in the tens place and the 9 is in the hundreds place when we add to get our final answer. Place value is a key concept in deeply understanding mathematics. We can use the properties and split the numbers up into their parts to figure this out. So that 49 times 25 is 49 times 20 plus 5. Student B used a method that is sometimes called partial products of 9 times 5, 40 times 5, 9 times 20, and 40 times 20. Another way to write this, which uses the distributive property more clearly, is 49 times 25, written as the quantity of 40 plus 9 times the quantity of 20 plus 5. The method of both students are valid. One of the major ideas in this text is that there are multiple ways, often called solution paths, to get an answer. There is no one right way to solve any math problem. This may be different from what you have always thought about mathematics. You may have even had teachers who marked you wrong if you did not solve it their way. As a teacher of elementary school mathematics, a deep understanding of mathematics will enable you to respond to the above type of situation in an elementary school classroom. Simply being able to get the right answer is not sufficient. Teachers need a specialized understanding of mathematics that is flexible, connected, and conceptual. Teachers use mathematics every day in the classroom, but in different ways than other people. In 1986, Lee Schulman used the term pedagogical content knowledge to refer to this specialized understanding of mathematics, which includes an understanding of multiple representations and examples, plus an understanding of what ideas may be more difficult for students and why these ideas are more difficult. In 2008, Deborah Lowenberg Ball, Mark Thames, and Jeffrey Phelps developed the framework depicted in Figure 1.1, showing different types of knowledge. This book is focused on specialized content knowledge, which includes understanding multiple representations and multiple student procedures and analyzing student errors. It is the type of math content knowledge that teachers draw on every day. Understanding students' errors. How do you think the answer was produced? What do you think the student was thinking that led to this error? How does this type of scenario draw upon specialized content knowledge? Analyzing student errors draw upon specialized understanding of mathematics, and that the teacher needs to understand the mathematics deeply in order to identify the error and then help the student to correct the misunderstanding. This student does not understand that in the second step we are actually multiplying 20 times 49, so it should be 980, not 98. While most people could get a correct answer for 49 times 25, teachers need to understand the concept much more deeply. Many of us experienced elementary school mathematics as a series of procedures to memorize, like multiplying 49 times 25. In order to teach true understanding of mathematics, teachers must develop this specialized content and a mathematical growth mindset. Mathematical problem solving. A useful metaphor for problem solving is a toolbox. Some useful tools to explore in solving math problems include drawing a picture, making a table, using algebra, guess, check, revise, using concrete materials, looking for patterns, solving a simpler problem, and visualization tools. Consider a few problems you have had in your life, and not necessarily math problems. What steps did you take to solve these problems? Use this recollection to make a list of general steps that you take to solve a problem. Then read on to learn about a mathematician that made a similar list. Your list will likely be pretty similar to his. There are many kinds of real-life problems that you may have considered here. One that many of us have dealt with is what kind of car to buy. The first step would be to understand what you need. How many seats do you need? What is your budget? Is gas mileage a priority? What models do you like? This part might be called something like understand the problem. Did you have a step like this in your list? The second step would be to develop a plan. Where will you look? What research will you do? The third step might be to carry out the plan. Research the best models, look around for the best deals, test drive some models, and find the one you like. The next step, hopefully before actually buying the one you have your heart set on, might be to look back and reflect on whether it really meets your needs, fits your budget, and so on. Read on to see how this procedure is the same for solving a math problem. Polya's 4 steps. George Polya developed a framework that breaks down problem solving into 4 distinguishable steps. In 1945, he outlined these steps in a now classic book he called How to Solve It. 4 steps of problem solving. Step 1, understanding the problem. Questions that can be useful to ask. Do you understand what the problem is asking? Can you state the problem in your own words? That is, paraphrase the problem? Have you used all the given information? Can you solve a part of the problem? Actions that can be helpful. Reread the problem carefully. Often it helps to reread a problem a few times. Try to use the given information to deduce more information. Plug in some numbers to make the problem more concrete. Step 2, devising a plan. Several common strategies. Represent the problem with a diagram, carefully drawn and labeled. Check to see if you use the relevant given information. Does the diagram fit the problem? Guess, check, and revise. Keep track of guesses with a table. Make an estimate. These estimates often serve as a useful check. A solution plan often comes from the estimation process. Make a table. Sometimes the clues come from adding a new column. Look for patterns in the problem or in your guesses. Be systematic. Look to see if the problem is similar to the one you have already solved. If the problem has ugly numbers, you may see the problem better by substituting nice numbers and then thinking about the problem. Break down the problem into a sequence of simpler, bite-sized problems. Act it out. Step 3, carry out the plan. Are you keeping the problem meaningful? On each step, ask what the numbers mean. Label your work. Are you bogged down? Do you need to try another strategy? Step 4, looking back. Does your answer make sense? Is the answer reasonable? Is the answer close to your estimate, if you made one? Does your answer work when you check it with the given information? Note that checking the procedure checks the computation, but not the solution. Can you use a different method to solve the problem? Using Polya's 4 steps, we encourage you to use Polya's 4 steps in all of the following ways. Use them as a guide when you get stuck. Don't rent them, buy them. Buying them involves paraphrasing my language and adding new strategies that you and your classmates discover. For example, many of my students have added a step that helps reduce anxiety. First, take a deep breath and remind yourself to slow down. After you have solved a problem, stop and reflect on the tools you've used. Over time, you should find that you are using the tools more skillfully. This is where we'll stop. You can investigate the PowerPoints further. There's another 100 slides. But the main goal and main takeaway is to have a more positive attitude toward math, to develop a deeper understanding of math, and to start practice using problem-solving methods such as Polya's 4 steps of problem solving.